Okay, so for these graph problems, it's really helpful to visualize an example and to work through a drawing. So here I've drawn out an example where we have 3 distinct islands, so 1, 2, and 3. And an island is just defined as basically a landmass where the ones are attached to one another through the cardinal directions, so up, down, left, and right. And basically, what we want to do is to just iterate through this matrix. And each time we hit an index with a 1, we want to start a depth first search in order to change all of the ones in a piece of land like this into zeros. And then after we've turned the entire island into all zeros, we then return a 1 in order to account for the unique island. So in order to do this, we will eventually write a depth first search function called sync. So here, I've written that at sync 0, 0, we see that there's a 1, and so we change that into a 0 in our recursive call, and then that call calls on sync of 1, 0. So we visit the neighbor below, and then we sync that island. And then for sync 1, 0, we visit its neighbor below, and we see that it's already a 0. And so our recursive call will then return 0 for that. Okay, so now we check the neighbor above, which is already a 0, so we return 0, and then we check to the left, which is out of bounds. Again, we return 0, and then we check to the right, which is a 1, and so we make it a 0. And then we do the same thing for sync of 1, 1. We check its upper neighbor, which is a 1, so we return 0, or so we make it a 0, and then we check the neighbors of, let's see, this is 1, 0. Okay, and so above, out of bounds, return 0, below already a 0, left already 0, right already 0. And so in that case, we can return 1, and we return up the call stack until we reach back here, in which case we know we've checked the bottom, up, left, and right. And then so we return a 1 for the entire landmass. Okay, so now we iterate through continuing on here, we see 0. And we're not interested in the 0, so we're only interested in starting a depth first search when we see a 1. So here we see another 1. We check above, below, to the left, to the right. In this case, everything's a 0. And so that means we return 1 for that island. So the total number would be 1 plus 1, which is 2. And then we continue onwards until we hit this landmass, in which case we do the same thing that we did up here. And once we've sunken the entire island, meaning we've made it all zeros, we can return up the recursive stack and add a 1 to the total number of islands, making our answer 3. So now let's look at what the solution looks like in code. As always, I've outlined the general structure in the comments, so if you would like, you can stop and try it out yourself. So what we want to do generally is to have an int that tracks the number of islands and to eventually return that number. And how we do this is we need to search through all of the elements in the array, or all the positions in the matrix, in order to see whether or not we've hit an island. So let's do that here. We ask if grid ij is equal to 0, or sorry, is equal to 1, indicating that it's an island, then we increment the number of islands, but by how much? Well, if we look here at this example, we want to count this entire landmass of ones as one island because they're all connected either like by the top, bottom, left, or right to one another. And so we want to return sync grid ij. And once we write sync, you'll see that it's a depth first search version of syncing all of the neighboring islands and then returning 1 for the entire land mass. So let's do that now. Okay, so first we check the bounds. If I is less than 0 or I is greater than grid dot length. And same for j. Sorry, that should be greater than or equal to j. So if they're out of the bounds, or if grid ij is equal to 0, meaning that it's in fact not an island, then we return 0 because we don't want to count that as an island. However, if grid ij is an island, then we sync the island, meaning that we set the cell to 0. And then we want to make sure to use a depth first search sync of all of its neighbors. So we sync the bottom, and then sync the top neighbor, the left, and the right. And then finally, we return 1 because we count the entire landmass after syncing all of its neighbors as one island. And then we add that to num islands here. And eventually, when we're done iterating through the entire array, we should have hit all of the unique, or I guess all of the separate islands. So here we return 3. Okay. And let's submit. And there we go.